In this series, Thinking Recursion in Java, we will learn how to think recursion and solve coding problems in Java using recursion. So in the first video of this series, we will look at how to think about recursion. So recursion in 4 steps. It's a very powerful technique to think and solve the basic problems of recursion. And then we will look at a few sample code exercises. Sum of n numbers, power of 2, factorial of n, and the really famous Fibonacci numbers, and solve all these problems through recursion. And in that process, we will also learn how to think recursion, how to approach a problem in recursion. So what is this process? Recursion in 4 steps. The 4 steps are: break the problem into a smaller problem. Once you have started breaking the problem into a smaller problem, generalize the solution, specify the base condition, and then write the code. So in a series of sample problems, we will apply this 4-step process, and in that process, we will learn how to use it. So let's look at our first problem, sum of first n numbers. And what does our step say? What is step 1? Break the problem into smaller problems. So let's look at an example, sum of first 5 numbers. So what are the numbers we are wanting to add? 1 plus 2 plus 3 plus 4 plus 5. And now how can we break it up into a smaller problem? We can obviously write this as 1 plus 2 plus 3 plus 4 with a plus 5. And this, you can see, is the sum of first 4 numbers plus 5. So the sum of first 5 numbers can be written as or broken down into a smaller problem, which is the sum of first 4 numbers plus 5. Let's look at another example. Let's look at sum of first 4 numbers. So that is 1 plus 2 plus 3 plus 4, which we can write as 1 plus 2 plus 3 plus 4. And what is 1 plus 2 plus 3? It is the sum of the first 3 numbers plus 4. So the sum of first 4 numbers can be written as sum of first 3 numbers plus 4. Now that we have understood this pattern, can we generalize it? That's the second step. Generalize the solution in terms of n. So the sum of first n numbers is 1 plus 2 plus 3 plus so on till n. Now we can write this as 1 plus 2 plus 3 plus so on till plus n minus 1 with an n plus n. Now what does that become? It is the sum of first n minus 1 numbers plus n. So now we have generalized it. So the sum of first n numbers is actually the sum of first n minus 1 numbers plus n. And if we denote it as sum n, we can say sum n is equal to sum n minus 1 plus n. So this is a very, very important step in recursion. This looks simple, straightforward, but always try and write that problem in a generalized solution in terms of n. And right now, as you start to understand, n is one of the most important variables in that problem. You're calculating the sum of first n numbers. What is the next step? Specify base condition. Now what do we mean by that? Think about the smallest problem and check for the value of the smallest value of n. So what should be the value? So in this case, if we are finding the sum of the first n numbers, and let's say n is 1 or more, then what is the sum of the first 1 numbers? That will be sum 1, which is equal to 1. So we cannot break this problem into a smaller problem because the smallest value of n is 1. So this is referred to as the base condition. What does the base condition really mean? Base condition means that at this point we know the value and no more recursion is to be applied. So if we recap it, what do we get? We get sum n is equal to sum n minus 1 plus n. That is what we got from generalizing it. The second is the base condition, which is sum 1 is equal to 1. Once we know these two things, we can go to the step 4, which is write the code. So here, let's just write the code. So let's define a function static int sum. And what does it take? It takes a number n as parameter. We will first check for the base condition. If n is equal to 1, then return 1. That's what we said. Else, what should it be? We can just say return sum of n minus 1 plus n. That is what we said as the condition. So this is how we have written that expression. Now let's just go ahead to run it. Let's just say sum 5 is equal to, let's call that function. And now if we run it, what do we get as the output? We get sum 5 is equal to 50. Let's make it say sum 4 and run it. So what do we get as the output? Sum 4 is equal to 10. So this is exactly what we wanted. So once we were able to express it in those two forms, the generalized condition and the base condition, the generalized solution and the base condition, we can see that is exactly what we converted into code. So that is our 4-step approach. Let's go ahead and apply this approach on a few more exercises. Use recursion to calculate the value of 2 to the power n. So we need to compute the nth power of 2. And what has been given to us? Note that n is greater than equal to 0. So the minimum value of n is 0. So what are our steps? Step 1 is to break problem into smaller problems. And let's take some examples. So 2 to the power 5. So what is 2 to the power 5? 2 into 2 into 2 into 2 into 2. Now that you can obviously write as 2 into 2 into 2 into 2 4 times multiplied by 2, and this we can denote as 2 to the power 4 into 2. So now you can see that 2 to the power 5 can be written as 2 to the power 4 into 2. So we have broken that problem into a smaller problem. Let's look at another example. Let's see 2 to the power 4. So that is 2 into 2 into 2 into 2. So that can be written in this manner, 2 into 2 into 2 multiplied by 2, which is 2 to the power 3 into 2. So we have been able to break this problem in these two examples into a smaller problem. Let's generalize it. So 2 to the power n is 2 multiplied n times. And obviously we can now see that we can say 2 into 2 into 2 n minus 1 times into 2. And what is 2 into 2 into 2 n minus 1 times? It is 2 to the power n minus 1 into 2. So 2 to the power n is equal to 2 to the power n minus 1 into 2. Now that we have generalized it, we need to specify the base condition. So think about the smallest problem. Check for the smallest value of n. What is the smallest value of n in this case? 0. So 2 to the power 0 we know is 1. So that is our base condition. So we know 2 to the power n is equal to 2 to the power n minus 1 into 2. And let us just write it in this format so that it's easier to code. So power 2n is equal to power 2n minus 1 into 2. We're just writing this exactly same expression, but just expressing it in this format. And 2 to the power 0 is equal to 1. So power 2 of 0 is equal to 1. Once we know these two things, we can just go ahead and write the code. So let's define this function static int power 2. That's the name of our function. Let's use the same name that we give there, and it takes a parameter n. Now what is our base condition? If n is equal to 0, what do we want to return? Return 1. Else return power 2 n minus 1 into 2. That was our generalization. And now we can say here power 2 of say 5 or is equal to power 2. Let's run this code and let us see what do we get as the output. We get power 2 of 5 is 32. So 2 to the power 5 is 32. We know that. Let's say give it the value 10. What is the value of 2 to the power 10? The value of 2 to the power 10 is 1024, which is what we get. So exactly the same thing. So you can see here we wrote the base condition. If n is equal to 0, return 1. Else what do we return? We calculate the power 2 of n minus 1 and multiply it by 2, which was our generic condition. Let us look at another exercise. Calculate the factorial of n, which is denoted as n factorial. So factorial here is denoted with this exclamation mark. And note that n is greater than equal to 0. And what we have been given that 0 factorial is equal to 1. Now what is factorial? Factorial of 5 will be 1 into 2 into 3 into 4 into 5. So the product of all the numbers from 1 till n is known as factorial of n. So again, the process, let's follow the 4 steps. Break problem into smaller problem. And let's take some examples so that we can break that problem. So what is 6 factorial? 1 into 2 into 3 into 4 into 5 into 6. Now as you can see, we can write it as 1 into 2 into 3 into 4 into 5 into 6. So which is 1 into 2 into 3 into 4 into 5 is 5 factorial into 6. So 6 factorial is actually 5 factorial into 6. Similarly, let's look at 5 factorial, which is 1 into 2 into 3 into 4 into 5, which can be written as 4 factorial into 5. So you can see we are being able to break this problem into a smaller problem. Now let's go to step 2, which is generalize the solution. So n factorial is 1 into 2 into 3, so on till n, which we can see we can write as n minus 1 factorial into n. So n factorial is equal to n minus 1 factorial into n. So we have generalized our solution. Next, what do we need to do? We need to specify the base condition. Typical rule about thinking about base condition is think about the smallest problem or check for the smallest value of n, which in this case is 0. So we have been given 0 factorial is equal to 1. So that's our base condition. So n factorial is equal to n minus 1 factorial into n. Let's just write it in terms of say a function named factorial. So factorial n is equal to factorial n minus 1 into n, and factorial 0 is equal to 1. So now that we have been able to break it, now let's go to our step 4 and let's write the code. So let us define this function static int factorial. It takes a parameter n. Now what is our base condition? If n is equal to 0, return 1, else return factorial of n minus 1 into, that was our generalized condition, and let's just say, so let's say 5 factorial is equal to and let's just run it. So what is factorial of 5? Factorial of 5 is 120. 2 into 3, 6. 6 into 5, 4. 24 into 5, 120. What will be 6 factorial? It will be 5 factorial into 6, which should be 720. Let's run it and check it. What do we get? We get 720. So notice again in this case, we wrote the base condition. So if we get the base condition, we return the value. We don't need to use recursion anymore. Else, return the recursive step. So this is referred to as the recursive step. Why is it called recursion? Because here to solve the value of factorial, we are using this same function again. So that is why this is referred to as recursion. Let's look at the next exercise, Fibonacci numbers. This is a very commonly asked problem of recursion and a very famous problem of recursion. Calculate the nth Fibonacci number. And what is a Fibonacci number? Given that each Fibonacci number is the sum of the two preceding numbers. The first two Fibonacci numbers are 0 and 1. So what have we been told here? If we want to break that problem into smaller problems, Fibonacci 2 will be the sum of the two preceding Fibonacci numbers, which is Fibonacci 1 plus Fibonacci 0. Similarly, Fibonacci 3 is equal to Fibonacci 2 plus Fibonacci 1. Fibonacci 4 is equal to Fibonacci 3 plus Fibonacci 2. Similarly, Fibonacci 5 is equal to Fibonacci 4 plus Fibonacci 3. So you can see we are being able to break this problem into a smaller problem. Can we generalize it? Yes. Fibonacci n is equal to Fibonacci n minus 1 plus Fibonacci n minus 2. Now what are the base conditions? In this case we have two base conditions. Fibonacci 0 is equal to 0 and Fibonacci 1 is equal to 1, which were specified to us. So why do we need two base conditions here? We need two base conditions here because we need these two values to be able to get the first value here. So this is important. As you start solving problems, you'll be able to intuitively develop it, what is happening. So Fibonacci 2 is equal to Fibonacci 1 plus Fibonacci 0. That's the first or the smallest problem being used in recursion here. So we need Fibonacci 0 and Fibonacci 1. So what all do we have here? Fibonacci n is equal to Fibonacci n minus 1 plus Fibonacci n minus 2. Fibonacci 0 is 0. Fibonacci 1 is 1. So we can now just go ahead and write the code. Let's do that. Static int Fibonacci. So here what are our conditions? If n is equal to 0, return 0. Else if n is equal to 1, return 1. So we had two base conditions. Else return Fibonacci of n minus 1 plus Fibonacci of n minus 2. And let's print this. So Fibonacci of 3 is equal to if we run it, what do we get? So Fibonacci 3 is 2. We can also put in just a for loop and print the first 10 Fibonacci numbers. Let's do that. For I is equal to 0, I less than 10, I plus plus. System.out.println. We should do it. So now if we run this code, what do we get? Fibonacci 0 is 0, Fibonacci 1 is 1, Fibonacci 2 is the sum of the preceding ones, which is 1, Fibonacci 3 is 1 plus 1, which is 2, Fibonacci 4 is 1 plus 2, which is 3, Fibonacci 5 is 2 plus 3, which is 5, Fibonacci 6 is 3 plus 5, which is 8, Fibonacci 7 is 5 plus 8, which is 13, Fibonacci 8 is 8 plus 13, 21, and so on. So what we have seen here is the first video in the series of recursion, and we have solved some very basic questions of recursion. The codes would be given in the description, so you can use those codes. And in the next videos, we will look at more problems of recursion. And at the end of this series, as we said, you will have a fair handle of recursion and you will start writing complex codes in recursion on your own. So don't forget to subscribe, don't forget to stay and watch these videos. And my suggestion would also be, once you watch them, just go there and do these exercises on your own also. That would be really, really helpful. So think about recursion and understand and develop a good handle of recursion. It will help you in your careers.